Hello, welcome back, Anna. Welcome, Taylor. Welcome, Kutatana. Welcome, Claire, and welcome to this latest lecture in the A Star series. Today, what we're going to do, we are going to carry on with fractions, decimals, and percentages, which we started yesterday. So, yesterday we ran through decimals and fractions. So, today we are going to focus on percentages for a large part of the lecture, and then we will move on and have a look at conversions between fractions, decimals, and percentages as well. Um, just before I start, I'm just going to share in the chat the link to our YouTube playlist. So this lecture, as always, is being recorded. It will be uploaded to the first of the two playlists I've shared later. And for anyone not here, yes, so you can watch the first of the two on fractions, decimals, and percentages there as well. And then the second playlist below is the previous running of the series as well. So you might find that where you will find the topics from one series to the next are the same. So you can maybe jump ahead on a topic, but equally on some topics or even on most topics, just the nature of trying to fit things in. We don't fit in absolutely everything in one series, so it's often there's going to be some differentiation in the lecture from one series to the next. It can be a good supplement as well. And as always, as you can see here, I am going to share on the screen as I go through. And well, this class is in the form of a lecture. Please, if any of you have got any questions at any point, don't hesitate to ask. So you can either write them in the messages, or it's no problem to either just put up your hand or pop on your mic or anything like that as well. Okay, so as said, we are going to start today looking at percentages. Percentages is just a fancy way of sort of saying out of 100, and it's shown by this sign. So, yeah, so percentage is another way of showing a proportion of something where 100% is the total. And so by that notion, like anything less than 100% is less than the total. Anything more than 100% is more than the total. So just like with decimals too, or with fractions, which we've looked at, it can be another way to show the same pieces of information, and you're going to come across all of these within the exam. They're all very common topics, and they're all things you really want to be on top of. And also, as we're going to look at later today, you want to see the relationship between them. But we're going to look at, to start with today, we're going to look at percentage of an amount. In fact, I'll do it up here on the right. So calculating the percentage of an amount. And so A, we're going to look at the more fiddly of the two, which is without a calculator. And so to do this, the easiest way is to split the percentage into parts and add them together. Okay, so let's look at an example of a question here. So for example, let's say e.g. find 20, or if I just say find 36% of 150. And so what we're going to do to make up our 30% is to split this number into parts. And the easiest way to do that is to find 10%. And to find 10% of any number, you simply divide by 10. And so 150 divided by 10 equals 15. Remember, if a number ends in a 0, to divide by 10, you simply remove the zeros. But we've got 30% here, so then we can we've got 3 lots of 10%, so we can times that by 3, equals 45. And why we're timesing by 3 is to get 30%. All right, and so now we've got 10%. We can split our remaining 6% into 5% or 1%. So we can find 5%. So 5% is just going to be our 10% divided by 2. So we just got to do 15 divided by 2. It's not going to get exactly because it's an odd number, but it's going to equal 7.5. When we've done that, we've done our 10% of 5, we've done a 30% and our 5%. So that just leaves us one remaining percent. So find 1%. And for this, you could either do the original number divided by 100, or you can do 10% divided by 10. And so that would be 15 divided by 10. Where the number doesn't end in 0, the way to divide by 10 is to move the decimal point, which would be after the end of any number, one place to the left. And so it equals 1.5. And now we can just add these numbers together. So you've got to be a little bit careful here. I realise I don't have these numbers properly lined up, but make sure you add up everything in the correct column together, because we've got the 2.5s, which gives us 1, plus the 7 and 1, 8, so it gives us 9, plus the 45 equals 54. So that's our final answer, is 54. So this is always the way when you don't have a calculator to work out a percent, is to split in apart. So I feel I might have done something funny here actually. Oh no, I haven't. 0.36 times 150. Yeah, it's correct. I just put in my numbers wrong in my calculator to double check it. But all right, so that's without a calculator how you could do it. But we're going to look at as well with a calculator. Okay, so B with a calculator. And so divide the percent you are multiplying by 100 to make it a decimal. Then multiply your total by this. So what we do here, you do have 36% divided by 100, And if you divide by 100, it's like it goes a bullet point on, a decimal point on the end. It goes 2 places to the left, so equals 0.36 times 150, which is our total, and that's going to give us the 54 again. So very simple really with a calculator. Now I should say with a calculator as well, there is actually on scientific calculators, there's actually a percentage button if you use shift left brackets as well. So you could literally just type in 36% times 150. I tend to do it this way, which is a tiny bit more work, I guess, but means you're not having to know any fancy buttons, and it will work with absolutely any calculator in the world as well. And it's relatively straightforward. Plus, it practices the relationship between percentages and decimals, which is something you want to be on top of as well. All right, so I'll leave that there for 1 sec, and then we're going to move on to our next thing today. Okay. So next we're going to look at percentage increase. And so we'll look at A again without a calculator. Okay, so to work this out, we simply work out the additional percentage as the previous question, as the previous skill, sorry, and then add it on. So it's nothing too complicated here. It's nothing really different from what you've already done without a calculator. There's nothing too much to it. So now we've got, let's say, e.g., Jim had £3,200, sorry, £3,200 in the bank. He received 15% interest on his total, assuming he's taken nothing out. How much money does he have now? Jim's obviously got a better bank than I do anyway, but exactly. So all you would do here is to find 10%, which equals 3,200 divided by 10 equals 320, and then B, find 5%, which is 320 divided by 2, which gives us 160. Add them together, which is going to give you 480. And then the new total in effect, because whenever you've got a percentage increase, the thing to remember is your original is always 100%. So you've got the 100%, which is the 3,200. Then you've got plus 15%, which is the 480. And that's going to give you your final total, because effectively, if you've got 15% increase, you've now got 115% of the original, which is 3,680. And so that's why you'd end up here. So that's the important thing to sort of remember in percentage relations. It really helps with these questions, understanding the sums you're going to do, is but the original amount, the number it would start with, is always going to be the 100%. Or right. And so now we're going to look at percentage increase with a calculator. Okay, so to do this, basically, we add the increase onto the original 100%. Then we turn it into a decimal, and then we multiply by this. Okay, so it's nothing too much more complicated from what we've already done on our first skill. Again, it's just the important thing to remember is that you are adding your percentage onto the 100%, which is where you start. Okay, welcome Lynn as well. Okay, so we've got here, this is an example of a question. Pop it on, sorry, it's got a bit long here, but we'll sneak it in. So we've got Jane deposits £1,360 into her bank, which has an interest rate of 2.2% per year. Assuming that she does not deposit or withdraw any money, how much money will she have in a year's time? All right, so the thing to understand here is, so Jane starts with 100% and then adds the interest of 2.2%, which means she equals the end, which is 102.2%, which means the sum in effect we have got to do therefore is the 1360 times 102.2%. And remember, we want to turn this to a decimal, so 102.2%. So we need to divide by 100, which means that we move our decimal 2 places to the left. You could do it on a calculator anyway if you're doing it at 102.2 divided by 100, but you should understand this because this could come up calculator or non-calculator in terms of doing percentages to decimals. Percentage to decimal is divide by 100, so your bullet point will go 2 places to the left, and that's going to leave us with our new sum down here of 1360 times 1.022. And that's going to give us a new total of 1389.92. All right, so as long as you understand that you start with the 100%, whether you've got a calculator or non-calculator, percentage increase, it shouldn't be that bad. But the key to it is understanding that you start with 100%. Okay. So the next thing we're going to look at, similarly, we are going to look at percentage decrease. Okay. As always, if anyone needs to go back at any point to a previous slide, please just let me know. It's no problem. But percentage decrease. Okay. So we're going to do again. We're going to do 8 without a calculator. I mean, without a calculator, it's not going to change much from one thing to another. So to do this, I work out the percentage that it has gone down and then deduct this from the original. Just give an example question here, e.g. Amanda bought a car for £14,000. The car has, after a year has reduced to 60% of its original value. What is the new value of the car? Okay, so to work this out, we need to work out the percentage decrease. You could do this in a couple of ways, actually. You could do the decrease and take it off, or you could just work out the 60%. I'm going to do this one as a decrease and take it off, but you could do it. You could do it the other way as well. So to work out the decrease, so the decrease equals the 100% original minus the 60%, and so that equals 40%. And so 40% equals 10% times 4, so equals 1400 divided by 10, which gives us 1400 times 4, which you might want to write out actually if you were doing this. It's going to give us 5,600, but I wouldn't expect you to do that in your head. You could write it out as a long multiplication if you wanted. So this is 5,600. And so now we can say new price equals equals 1400 minus the 5,600. If we work out, we've got two zeros here. 0 take 6 you can't do. So you can borrow 1. 10 take 6 gives us the 4. 3 take 5 you can't do. And so 13 take 5 gives us 8,400. So this is option 1. And so option 2 is actually easier. Either way is fine, whatever you feel comfortable with. This is just find 60%. And so in this case, we could just do 1400 divided by 10 times 6, which is going to give us 840. Obviously, it's going to give us the same number again. As I say, if you're working out in the exam, I would expect you to write out the 1,400 times 6 as a long multiplication. Do as I say, not as I do with that stuff. It's always much better to write out your working along the way. But yeah, that's without a calculator. So we're going to look at with a calculator. Okay. So with calculator. So we've got, it's carrying on from the question actually we did with the calculator before. So one sec actually. So we've got here it's not really written as a question in the original place, but so it's basically calculate the new value if Jane decides to withdraw 25% of a total of 1389.92. So just as we've done without a calculator, we can do it the same. So we can say new value equals the original 100% minus the deduction 25%, and so equals 75%. So just like when you're doing percentage increase, really the key to this, it's nothing more to it, it's just remembering you start at 100%. If you can remember that, everything can be relatively straightforward from there. So now we can do the, basically we need to do 1389.92 times 75%. And 75%, if you want to make it a decimal, again, we can divide by 100, which is 2 times 0.75. As I say, that is actually a percentage button on your calculator if you hunt it down, but if not, you can do it like this. So you would do the times 0.75, and if you do that, it's going to give you an answer of 1042.44. And that is the final answer. That's nothing more to it. And that says welcome as well earlier. And yeah, if I'll just give a second again, just in case anyone needs to copy this, and then we're going to move on to a couple more things here. Okay, so we'll carry on from here. So next, what we're going to look at is simple interest and compound interest. And so you may get asked in a question to calculate either of these. And so you've got a simple interest, and basically this lives up to its name as the money goes up by the same amount each year, or goes up, or the money goes up, or by the same amount, or you could say the money received is the same, depending on the question, each year. So let's have an example of a question here. And it's nothing too complicated, simple interest, but it's just understanding the terminology. So you could say like Tati receives 15%, or Tati received 15% simple interest on the £1,600 in her savings account each year. How much had she received after 3 years? And so if it's simple interest, it means it doesn't grow, it doesn't compound, it doesn't go up. So all you'd have to do is A, find 15% of 1,600. And so to do that, we're going about a calculator here, so we can say 10% equals, well, it's 1,600 divided by 10 equals 160. 5% equals 160 divided by 2 equals 80. And so if we add them both together, it's going to give us £240. And we know it's after 3 years, so we can just say simple interest equals 240 times 3, which is going to get us equals 720. So nothing too complicated to that. Compound interest is a little bit more complicated, but it's not that. Sorry, I was sorry if you weren't let in earlier. To be honest, the link, I haven't seen the link come through to you sooner, Ali. I'm sorry for that. When it came through, when it made the sound for you coming through, I let you in within a few seconds, but apologies if you tried to join earlier and it didn't work. What I'll do for you, I'm just going to share again, I shared it earlier, but just a YouTube link for this series. So this lecture is being recorded as always, so I'll try and upload it immediately after this session, and then if you want to watch it back either later tonight or tomorrow, it should be there. Sorry about that, though. Okay, so we'll go from that. So we've got the simple interest equals 240 times 3 equals 720. Now, compound interest, and compound interest is something, it's funny, people often in the maths exam when they're going to like teach in primary schools wonder, say anything I actually really need to know. Compound interest is one of those things you really could do with understanding, and probably a lot of you are very familiar with it anyway, because if you've got a credit card bill or a mortgage or whatever it is, the way the interest will be worked out is compound interest. And so compound interest, this is interest that grows on, through, I was going to say, year on year. It wouldn't have to be year on year, to be honest. I'm putting year on year now because it's normally year on year in the exam, but it can often be with a credit card or something, it'll be month on month. Sometimes even with some of these debts, it will be day on day, but the new amount, the new interest is calculated on the increased amount. And so this will normally be in your calculator exam, and is, or if it does come up, if I'm not saying it will always come up, but if it does come up, it will normally be in the calculator exam, and it's simple to work out if you know how. So if you know how to use the calculator. So yeah, say for example, let's say, e.g., let's say Matthew bought a house for £216,000. The price of the house had a compound growth. So compound growth is no different to working out compound interest. It would mean the same thing, of 12.4% for 3 years. What is the new value of a house? So some people, even if I understand it, they might go through painstakingly doing it 1 year after another, but you don't have to do that. So we've got here, we've got our original, the 216,000, which is 100%. So that's the thing to remember. The original is still 100%, plus 12.4% equals 112.4%. And so to calculate compound interest, we simply add a power for the number of years in our calculation. So remember 12.4%, we're going to calculate as a decimal in our calculator. So we're going to divide that by 100, which as always is to move our decimal point 2 places to the left, so equals 1.124. And so now the calculation we're going to put in our calculator is just simply 216,000 times 1.124 to the power of 3. Now I'm just going to show you briefly where the power buttons are on a calculator. You do have, actually let me put in the numbers first. So we've got 216,000 times 1.24. Now you do actually have a power of 3 button. So if you see in the x's we've got here, we've got one which is x squared, where you can press the power of 2. Here we've got x cubed. You've also got one here which is x and a blank square. So if you have to do a power higher than cubed, you can press this button, x blank square, and add in the amount of years or the power you need to put in. So in this case it's to the power of 3, and it will do the work for you. So it's going to come up, it comes up with 411.830.784. It's money, so whenever you do money, you leave it to 2 decimal places, as that's what we calculate money in. And so 0.78, the number of the 8 is lower than a 5, so we stick the same. 411.830.78 would be the final answer. All right. So move on from that in a second. We just got a couple more things I want to show with percentages, and then we're going to just briefly touch on. We're going to briefly touch on how to do conversions between fractions, decimals, and percentages. All right. So next one we're just going to mention quickly is reverse percentages. Reverse percentages. We're just going to look at these with a calculator because it's the way you would normally get them. So you may get a question where you are given a part percentage and you need to get to the total. So actually, no, I will show briefly without or with a calculator. So A, you could say, let's say without a calculator. And so to do this, you generally want to find 10% and then multiply that by 10. That wouldn't necessarily work with every calculation in the world, but the calculations they would give you with a non-calculator in the exam, it should be possible. So let's say, e.g., a car costs, let's say £14,500 with, actually no, let me change that. Let's say 1,200, £12,600 with 20% VAT added to its price. And so what was the cost of the car without that? What is, so it should say, what is the cost of the car without that? All right, so to calculate this, so original plus that equals 120%. So equals the 12,600. So that's the total we've got at the moment because we've got the price with that. It's not 100% of the original. It's the original, which is the 100%. Plus the 20% VAT, and so it is 120%. And so therefore, A to find 10%, we can divide by 12. And that's good. If you have 50%, you divide by 5. 60%, you divide by 6. Here we've got 120%, we divide by 12. So you can remove the 0 and divide by that, and that's going to get you 10%. So we can do here, I'm going to do it as a bus stop. So we got 12, into 12 goes 1, into 6 doesn't go, into 60 goes 5. So we got 1 equals 1050. And so that means the original, which is 100%, equals 10% times 10. And so we've got 1050 times 10. It just means we add a 0 on, equals 10500. And so that would be the price without that. All right, and you can use that method with a calculator as well. There's nothing wrong with doing that. You can divide to get 10% and then multiply by 10. But then there's another method with a calculator. So beat with a calculator. To do this, we find out what percent of the original we have, and then divide by this. So you could say a television has been reduced in price by 25% and now costs, let's say, £560. What was the original cost? All right. And so first of all, we can just say the new price equals the original minus the deduction. And so the original is always going to be 100% minus 25%. And so that's going to, I don't know, I've gone back to front, but never mind. That's going to give us 75%. And so now to find out the original price, we need to do, so original equals 560 divided by 75%. 75%, which again, we're just going to do what we've done before. We're going to turn our percent to a decimal, going to divide it by 100 equals, so 560 divided by 0.75, and so 560 divided by 0.75, and that's going to give us our nearest pence. It's giving us a recurring number actually, but we can say 746.67. It might seem confusing if you're dividing when you're going to get a bigger number, but if you're dividing by less than 100%, your number's going to go up. If you're divided by more than 100%, your number's going to go down. It all plays in with keep, change, flip, and all the stuff we've done with fractions earlier. It all links together. So say if you were doing the previous question with a calculator, you could have done 12,600 divided by 1.2, and that would have got you to the answer. All right, so one sec for that, and then we're going to move on to our final percentage rate. Okay, so our final percentage scale we're going to look at for now, our individual percentage scale, and this really leads into conversions, because what you're doing here is basically what you do in conversions as well. So to calculate percentage change, you need to remember the following formula. And so percentage change equals, and it's change, and I should be clear here, it might be better to call change the difference. I'm just going to put diff here in brackets because it's a bit confusing. It's percentage change and change again, divided by the original, and then times 100. And as we're going to see later, what we're really doing here is fraction to decimal to percentage, because if you do the percentage change divided by original, it's like you're writing it down as a fraction, but if you divide the numerator by the denominator, you turn it to a decimal, you times 100, you turn it to percentage, but we'll see that in a minute. But let's give example of a question here. And this equation, it works whether something has gone down in value or up in value. The important thing is you have the correct original. So we've got here, calculate the percentage change when a car goes down in value from 8,500 to 7,000. So first of all, we want to calculate our change or our difference. So change equals 8,500 minus 7,000, and so equals 1,500. And so next, we need to work out which part is our original. Well, the original is always where it's gone from. So it's gone from 8,500. So now we've got this, we can write out our equation. So we know it's going to be 1,500 over 8,500. And if you think that's basically writing the percentage change as a fraction over the original, but also the fraction can mean division. So we're doing 1,500 divided by 8,500 and then times 100. You would definitely be given a calculator for a question like this, unless it gave very simplistic numbers. But yeah, if we put that into our calculator, this gives actually quite a long answer. It's giving us 17.647 ... That's not a set rule. If you haven't been told how many decimal points to give something to, my instinct would normally be to do to 2 decimal places. So our second decimals are 4. The number after it is a 5 or higher, so it equals 17.65% to 2 decimal places. So I would say this percentage change equation or formula, whatever you want to call it, it's quite an important one. It's quite a useful one to know, but also see how it relates with sort of fraction to decimal and percentage, and then it's like learning 2 skills for the price of 1, because we're going to look at that in a second and we'll see it's exactly the same. Okay, so that's what we're going to move on to now. So conversions. So basically, fractions, decimals, and percentages can all be ways of showing the same information. It's therefore important to know how to convert between them. And so below, I'm just going to put is a table with some key conversions. I'm not going to go through all these key conversions, but when I say some key conversions, these are ones, it's quite good if you know some of these off by heart. You don't need to know all of these off by heart. but it's good to know some of these off by heart. It's going to save you time in the exam, just like knowing your times tables off by heart. If you can know the relationships between common fractions, decimals, and percentages off by heart, it's just going to make things a lot easier to follow at times. So you've got here, you've got like half equals 0.5 equals 50%. Hopefully you know that. I would say once and off by heart, it's great to know a third and 2/3 off by heart because they're both recurring, so they can be a bit fiddly if you don't know them. But if you do know these off by heart, well, you don't have to, as long as you know the methods, it's going to make your life easier, and just having that understanding of the relationships between fractions, decimals, and percentages can be very helpful. But what we're going to look at over here, we are going to do fractions to decimals to percentages. And so, in effect, the way of doing this, as already mentioned, is the same as percentage change, because you're just going to do, in effect, numerator, which is what the change would be on the other formula, divided by denominator times 100. Right, so let's have a look at an example here. So let's say e.g. to write 9/20 as a percentage. So A, we need to do here, we need to do fraction to decimal equals the numerator, so 9 divided by 20. Now you might have a calculator to do this, which is great, but if not, we're going to have to use the bus stop method. And be careful, because the number you are dividing by is always going to be the one outside. So it's a little bit, it seems illogical because the bigger number is going to be outside here. But that's because, of course, if our numerator is bigger than our denominator, our answer is less than 1. So, of course, 20 can't go into 9. So, effectively, what we've got to use, we've practiced this before in a bus stop class on division, but you need to basically use that method when you give your remainder as a decimal. So 20s into 9 doesn't go, so we need to add our 0 and add a decimal above and below the line. Now any number you can write 0.000 forever, so we can add a 0 here and we can put our remainder here of 9. So now we're doing 20s into 90s. We're just like 4 2s are 8, 4 20s are 80, so that goes 4 times. And we can add another 0, and now we've got remainder 10, because it was 80, 90 take 8 equals 10. Now we do 20s into 100, and that gives us 5. So that's our first part. And so B, we want to do decimal to percentage. Well, we've been doing percentage to decimal class in divide by 100, and so this is the opposite, which equals times 100, or 2 places. Right, sorry, I'm squeezing in that wide at the bottom. So what that means is decimal goes 2 places right, so we've got 0.45 times 100. Well, our decimal is going to jump over these two numbers, 2 places to the right, equals 45%. And that is our our final answer here. All right, so I'll just give a second to copy that, and then we're just going to briefly look at our final thing today, which is percentages to decimals to fractions. Okay, so we've got percentages to decimals to fractions. Now we're going to show all the stages. You could potentially skip out a stage here if you wanted, but we're going to go one to the next, to the next. So you get, say, e.g., write 4% as a fraction. I'm going to just add a little thing in its simplest form. Okay, so what we're going to do here is a percentage to decimal. And you could, if it's a percentage, if it's out of 100, you could skip this out, but I'm going to show it the whole way. So all we do here is divide by 100. So we've got 4 divided by 100. You've got to be a little bit careful here, because remember, the decimal point, which will be after 4, goes 2 places right. And that means we've got a 4 as one place, so we need to add a 0, so equals 0.04. And then B, and this is one not everyone realizes how to do, but to turn a decimal to a fraction, work out what value column the last digit of your decimal is in. This becomes your denominator. The number is your numerator. So what do I mean by this? Well, if we look at 0.04, the 4, well, the 0 is in the tenths column and the 4 is in the hundredths column, which means one of these is equals 100th of a whole. 100 of these equals 1, which means we can just write this number on its own as our numerator. 4 over 100. Well, our question said to write this in its simplest form. So we're going to, you could divide by 2 twice. We're going to divide by 4 because 4 is going to 100. Equals 4 divided by 4 equals 1. 100 divided by 4 equals 25. So equals 1/25. Okay, so I'm just going to show one more of the second stage here just to make that clear. So B, I'm going to say write 0.3 as a fraction. And so all you got to do here, we don't have to do the first stage already as a decimal. Well, 3 is in the tenths column, and so it will just be 3 over 10. So exactly whatever column the last digit is in, that becomes the denominator. The number without the decimal points, so 0.3 becomes 3, 0.04 becomes 4, whatever it is. If it was 0.24, it will become 24. That becomes your numerator, and that's all there is to it. In this case, we can't simplify it, even though the question hasn't asked us to anyway, but we can't, so that would be our final answer. All right. Well, I'm going to leave it there for today. So, yeah, thanks a lot to all of you for making it along on this Friday night. And, yeah, hope you all have a brilliant weekend. And then we're going to be back next Thursday at 7 15. So I'll just double check what we're doing next week because I can't remember. Oh yeah, we're going to be looking at next week. We'll look at ratios on the Thursday and then probability on the Friday. Yeah, no problem at all. Have a good night, everyone. Okay, you're welcome. Bye bye. Bye bye.